Hello everyone, I'm Axel. I'm a software developer here, Futurice, doing JavaScript stuff on web and on mobile for 5 years or so. And TypeScript, it's a cool thing, I like it. And this presentation is about a very specific library within the TypeScript ecosystem. So if you don't have any idea about what TypeScript is, or you haven't used it, then this presentation might be a bit alienating, and sorry about that, but hopefully you can learn something about why you would want to validate input data that you read from an API into your typed language. But if you're using Python or JavaScript without any typing, it doesn't really matter. So Iots, what's that? Don't worry, it doesn't have anything to do with IoTs. So it's not like Apple's HomeKit rebranded or anything like that. It's not like Io, the moon of Jupiter, telemetry system or anything like that. It's Iots, so input and output for TypeScript. And actually, nobody uses it for output, so it's like input for TypeScript. Reading data. Yeah, it's simple. And it's awesome also. And the author of Iots says that it's like a TypeScript compatible runtime type system for IO decoding / encoding. And I don't know what that means. So I say that it's like a data validation library with good TypeScript support. So if you need to know what your data looks like, you can use Iots, and it will tell you. You might ask, I already have like data validation for my input forms, or I don't have user input in my application. Why do I need to validate any data? And I'll have a short demonstration about what can happen if you make false assumptions about the data that you happen to read from an external source. You don't always have control of what your the systems that you're interfacing with. So here's a really short example of how one might use an API. We have some raw data, and then we have this fake API function, which is a promise-based. It reads the data, parses it as JSON, and resolves the promise. And then we have a function consuming the API. So we call the API, and when we get a result, we print the total price of our product, which is, of course, the price plus the taxation on top of it. Do you know what the result will be when I run the code? Of course, 10 plus 2.4 is 12.4, right? Easy math. Nothing can go wrong. And it's, whoa, no. OK, yeah, so it's a bit wrong. You can see the total price is now 102.4. And the obvious reason is, of course, that here in our formatting, we treat the values as numbers, but in reality, they are strings. Because, well, our API happened to be in string formatted number. It could be a bug on the back end, or it could be poorly documented behavior on the back end, or it might be basically any reason that the data is not what we expected it to be. And since JavaScript is such a lovely language, string plus string is, of course, a concatenation of those strings. Why not? So here, the code you don't have an exception anywhere. Nothing crashed. The code behaved like JavaScript expects code to behave, and it just prints a completely wrong number. Now you might say, but hey, I have TypeScript. I don't have issues with runtime. I know all of my types. So taking the same code, you have the same API, you add some type annotations. Here you even have this like nice interface of a product that says, yes, price is number, VAT, it's also a number. We have our API, it returns a promise with the product. We even have this fancy helper function which calculates the total price. So taking a product, it produces a number. And TypeScript ensures that, yes, product price, that's a number. Product VAT, that's a number. The result is always a number. We run our code, API, then product, and the total price. What will it be this time? Ideas? Let's see. Of course, TypeScript is so awesome that, whoa, it produces the same result. How nice. Well, the types didn't help that much. Like these, now of course they're next to each other, so you see what's going on, but it could be like 10 levels of nested functions and files and layers and libraries and whatnot in between if you have a really large product. And you trust your types as your product. Your project grows, you trust that, well, if the type says it's a number, then it must be a number. And still, we can bump into situations where we show something wrong to the user. And of course, the issue is here that JSON.parse, you can see that it returns an any. And in TypeScript, any means it can be any value, but it also means that we can treat it as whatever we want. We can cast it to anything, and TypeScript won't say that it's a problem that we treat any as a number or we treat any as a string. And that's a design decision by the TypeScript team, and I'm not really sure it was the best decision. They've kind of started to think about that maybe any isn't the best case in everything. So there's, I think in 3.something, there's a new type called unknown, which is any, but you can't cast it to anything. Like it's any, nothing. Well, it's you can put any value into unknown, but unknown cannot be cast into anything without the proper type checks. So that's kind of helping it, but because the standard library JSON.parse still produces an any, it doesn't produce an unknown, we have to do something about it ourselves. Luckily, now we get to Iots finally. So luckily, there's a library called Iots, and giving the same raw data, we, instead of just saying that we have a TypeScript type with a field called price and a field called vat being numbers, we introduce what Iots calls like a runtime type checker. So instead of having just a TypeScript type, we now have like a runtime constant from which we can produce the TypeScript type of product. And now our API call looks a bit different. We still call the API. We parse the JSON, but instead of immediately returning the raw JSON data, we pass it to our type, and it has a decode function. You can give it data, and then it will ensure that the output from that function is always of a specific type. And Iots uses this functional programming style, so it's an either, if that says anything to anyone, and either has either a failure or a success, being a left or a right, and you can fold it, and you can handle the errors, and you can handle the data if it validated correctly. And the rest of the code is basically the same. And now, if we run this one, it doesn't show the price, it shows an error instead. And this is usually helpful in applications to know if something went wrong, we have an error, and we can then behave accordingly. We can report it to ourselves into analytics and say to the backend guys, hey, this backend, it doesn't really turn what we expected it to do. And we can then show to the user, like, hey, there's an error with the backend, do not trust the data. Or like, we won't even show the data because we cannot trust it anymore. So it helps you to interface with APIs and then be able to rely that the data that you receive from those APIs actually is what you assume it to be. And it makes your life easier. So that's the demo. That's like the reasoning why you would want to use something like Iots, even though if you're not using forms or anything like that. So it can be like REST API, it can be reading data from files, from databases, from local storage, whatever that is not in your TypeScript runtime. It can even be like interfacing with another library, which you might not trust to always return the correct data. The happy paths usually go well, but if you have a product with enough users for a long enough time, sooner or later the data is not going to be what you expect it to be. Okay, so what does Iots do? So the TypeScript team, the developers of TypeScript, they have no intentions of supporting runtime checks. They explicitly say that, hey, we just annotate normal JavaScript. We don't change the runtime code in any way. So they won't help us. So that's why Iots exists. And the good thing about IoTS compared to something like Joy or any other data validation is that you get both the TypeScript type and the runtime validation from a single piece of code. So they're always in sync. There's no possibility of error there. And the library has a really strict like one-to-one mapping of all the types available in TypeScript, so objects and arrays and unknowns and nulls and undefineds. So they're directly typed to, or directly mapped to runtime type checks. And this then all helps the developer you to ensure that whatever you have in your TypeScript types, the runtime types will match that as long as you use the library. It has all of the types you could expect, basic types of strings and booleans and literals. You have arrays, either arrays of unknown length, or you can have tuples, which say like, for example, a coordinate. It has two numbers, x and y. You have objects, either with like defined, or you have partial objects, which might contain some fields, but might miss some other fields. Then there's like a record, which is like a mapping from, here the grades are a mapping from string to number, so you can have unknown amount of fields in the record as long as the key is always a string and the value is always a number. And then you can go like advanced. You can combine things with unions or intersections. You can have these stripping types, which removes all extra fields. For example, if you read a big object, but you only need 2 of the values, it will drop everything else so that you can maybe send it onwards without worrying about having something that you don't want to be there in the data object. So, and there's even more, like the documentation of the library is vast, and basically anything that you can define as a TypeScript type, you can define using IoTS types. And you can also write your custom types. And there's an example. This is basically the example code from the library homepage, but unfortunately the actual documentation of the library is very, how would you call it? It's very functional programming style, so they use very cryptic terms and they use very short function or variable names, so I try to document it here. But basically what a IoTS type consists of, they usually have a name. This is a type that reads a date from a string. It has a name, and then it has a type guard function, and this is like advanced TypeScript stuff. It's basically a function that says, given an object, it says like, is this object of type no. For IoTS usage, you don't really use it that much, so it doesn't always need to be perfect. The second function, this is the beef of the whole thing. It's taking an unknown input, validating it, and possibly transforming it. So in this case, we first ensure that it's a string, and if it's a string, then we try to create a date out of it, and if the date is valid, then we succeed. Not, then we fail. And the last one is the operation, but the other way around. So given a date, we produce a string. And this is like a bit complicated. You don't have to understand what's on this slide. Like, don't stress about it. And that's kind of the issue as well with the library, is that it's a bit hard to use at times, or hard to extend. If you use anything else than the pre-available types like object and array and string, if you want to do something complicated, something like I only want positive numbers, or I only want strings that are at least length 5 or something like this in your API validation, then you have to dig quite deep into like functional programming conventions that the IoTS library uses, and that's not always nice, but it's doable. Like if you're feeling adventurous, or if you feel like you understand how functional programmers think, then you might give it a try, but otherwise maybe just at first stay with the available types. So kind of final thoughts, don't overdo it, really. Like just validate with the existing type. Like it's directly maps to the TypeScript type. So you can get objects, you can get arrays, you can get strings, numbers, and so on. And then if you need to do any like extra processing, you can just do it with normal TypeScript code. Like if you have a string, you can look at the string and you can decide what to do with it. Or if you have a number, you can see, okay, is it positive? Is it negative? If it's negative, I'll do this. If it's positive, I'll do this. Because at that point, you already have the type safety. You already know what type the data is, so it won't cause any harm to do it there. But just for the initial layer of, hey, I have an unknown or any type coming in from an API, I have no idea what it is. Just validate the first layer and then do everything as you would do it otherwise. And like embrace the TypeScript types. They're really well supported by the library. Like if you can have a TypeScript type, use the similar Iots runtime types, but don't like try to make anything overly complex with the Iots types. That will just produce confusing code. And if you like want to look at the functional programming underneath, you can do the custom typing. You can look how the library is created and play around. It's based on another library called FPTS, which is like functional programming for TypeScript, which has support for optionals and so on. And that's also a nice library if you're into that kind of things. A couple of alternatives. One is a library I wrote yesterday, which is like Iots Promise. It's under construction, but it's on GitHub already. I can paste it later on. It's basically for making Iots easier to use with promises. So instead of having the weird code over here with the fold and the result. So instead of having to do this, the Iots promise library just allows you to do like decode and then that returns a promise which either resolves or rejects. So it cleans a bit of code and then it provides some helper for like if you want to create a new type or extend an existing type. Makes it easier to do that as well without having to worry about the weird stuff on this slide with the failures and success. It just allows you to throw an error if it doesn't work. And if it works, just return a value. And it will handle the processing there. It's not like complete in any way, but you can try it out and give feedback, and I might improve on it. And alternatively, there's another library called runtypes, which is quite similar to Iots, but only does the input side. So it's like only decoding values. I haven't used it ever. I just bumped into it. If somebody has used it, it would be really awesome to hear some like experiences or feedback or something like that. But at least the documentation didn't say how to extend it, how to create your own types based on it. And it didn't seem to have like this nice one-to-one mapping of everything that's happening in the TypeScript types. It had maybe its own idea of what the type should look like, and then it made it a bit hard to understand, like what do they actually mean, how do they reflect in TypeScript types. And then, of course, there are all the other data validation libraries, but they don't tend to have like perfect TypeScript integration. That's basically it. So it doesn't really matter what library you use, as long as you validate your input data so that you can be sure that the TypeScript types are real. Because if they don't, then your trust in the whole type system just falls down, and you're like, why did I get this runtime error? Like TypeScript is awful. I go back to Java Enterprise Edition instead. It has proper typing and so on. Like it can go ways out. But yeah, so that's my experiences with typing. Do them properly, and you'll save a lot of time. So questions or experiences with runtime type checking or anything else?
Thanks for the presentation. Just one quick question. Is there any runtime overhead for using it, especially for large data set, assuming that it can be used with TypeScript and Node on server side?
I haven't bumped into any. Like, of course, there's some. It has to traverse the data, and I don't think there's any support for streaming. So if you would have like a massive JSON and you would want to stream it through a generator and validate it on the fly, I don't think that's available. Fedor apparently has some pointers on it.
Yeah, I know to answer to this question. At least I've known it like a year ago or something. As far as I know, you can disable runtime checks. So pretty much you can use in development, you can have a full check. And then in production, it will just skip all the checks and just assume that the type is correct. So sort of you get all the errors in development, so you know they exist. But then in production, you will like skip the performance cost.
Yeah, that's doable. But of course, only do it if you actually have the performance problems.
But to me personally, if I want to turn it off on production, there's no benefit to use it. But of course, there is
Yeah.
benefit, but like you won't get the most out of it, right?
True. Yeah. So I
There's-
wouldn't recommend disabling it unless you
Yeah, it's
really
like-
need to press like all of the.
Exactly. And
Performance.
there's another question, if you may. In terms of using it in the client side for like web applications or website, is there any compromise on the bundle size too, or?
I haven't checked how large the library is. I think it's quite small. Fotis has some ideas on it.
6.3 kilobytes.
Okay, that will. Thanks.
I have a question actually.
Yeah, go ahead.
I think it's a bit of a follow-up to what was asked about the runtime performance. Is what I would imagine is that you only use this at the edges of your application, so the performance doesn't really, like, I would find it very hard to see a performance issue there, because you would only validate when you get the data in, and then you wouldn't be validating every single time as you go along. Which
Yeah, of course.
brings me to my question. Have you found any sort of architectural choices that emerge once you add this validation layer, so to speak, in your application? Like, does it fundamentally change how you handle data in your application when you have this validation step?
I'm not sure if it's a result of validation, but one thing I tend to do quite a lot, especially working with APIs, which we don't have control of, is like I read the data from the API and I process it with Iots, and then I basically like restructure the whole API into something that I would want to use. Like this is now writing client applications. I basically like design my own API based on visual designs. Like, hey, this value would be nice to have, this value would be nice to have, I would call it this. And then I just like read whatever garbage we get from the API, and then I map it with knowing that the types always match. I then transform it into the internal representation that I want to store in my state, that I want to use in my views. And I think that makes the rest of the code base clean. Of course, the API then looks like a dumpster fire of random like functions that try to sanitate and clean up the data, but at least it's contained in one single place.
Yeah, I just wanted to comment that I do the exact same thing on the trains.today Elm code. Like, the decoding file is just horrible, and there's like this huge amount of transformer code, but then the rest of the code base is like super neat.
Yeah. And usually it's a good choice to make, especially if you have a limited set of APIs, but then you might have a lot of UI built upon those small pieces of data. Then it really pays off.
Thanks for the presentation. I actually have two questions.
Oh.
Yeah. So the first one is, how does the default fallback of the type decoder or the coercer work? So for example, if you have an interface with a required key of a type number, but then if your API return actually a string A, how does that fall back to the number? And
So-
how well does it work with optional key, for example? So that's my first question.
Yeah, so
Yeah.
it will fail. So the decode will fail, and then you will have an error saying that I expected a string, I got an integer, or the other way around, I got an integer, I expected a string, and then like it won't return you any data.
Yeah.
You can create a type which allows for like either an integer or a string, and then it tries to decode the string, and if that succeeds to become an integer, it could like resolve with that, or like succeed with that value. So you can build fallbacks on that way.
Right. So I guess it's dependent on the decoder handler that you implement, or
Yeah, but those are like custom things that you would build yourself. Iots itself doesn't provide any like default or fallback values.
Yeah.
What you can do is you can use a union type. So that means that it's a union. So it could be either a string or an undefined or a null. So if it's not a string, it will return an undefined. If it's not an undefined, it will return a, like it would check is it a null, and if it's a null, it will return. And if it's a number, it would fail. And what you can, like if you want to have even more compatibility in a way, you can use the t.unknown, which is like the TypeScript's unknown, which anything can be an unknown, but you won't get any type information for it. So then you can like fall back to that, and then you can use some other code to check, okay, well, is it this, or is it that, or is it something else. So there's like ways to build fallback, but it's not really built into the library itself.
Yep. Thank you. That perfectly answered my first question.
Okay, the second one then.
So the second one is how does it work? Like does the IOTS type, the primitive type, is it compatible with TypeScript as well? So for example, if I parse in a variable of type T string to a function that requires TypeScript string, does it work the same way? Or do I have to also define the function as type T string as well?
No, so it is completely compatible with TypeScript. So there was in my example code somewhere. So here you can use this if you explicitly need the type as a TypeScript type, where you can pass it around or export. You can do like t.type of, and then type of the type, and it will be like a string, or it will be an object, or it will be anything. But it will also come like here in the result implicitly. So TypeScript will then like propagate it.
Your calculate total price returns a number, so it works nicely with TypeScript.
Yeah. So it's like a number, and it comes from there. And here you can see then like what the error looks like basically. So like invalid value string of 10 supplied to price number. So it expected a number, it got the value that is a string, and it said like, hey, no, I can't handle this.
Thank you. And also, turned out I didn't read the code at all. So
no worries. The slides and the example playground thingy will be pasted to Flowdoc, so you can check it out in detail after that.
Thank you, Axel.